Welcome to Archiversity online lectures. In this lecture, I am going to show you how to perform hypothesis test on categorical data. When you collect the data from your respondents on a nominal scale and ordinal scale, you get categorical data. So to test the hypothesis on a categorical data, that is whether there is any relationship between one category of a variable and another category of a variable, we use chi-square test. So in this study, we measured employees' education level on a scale of 3 items, that is a graduate, postgraduate and a doctorate. And then we sought employees' opinion on pace of the training program, whether the training program is conducted in a hurry manner or it is conducted in a leisurely or it is conducted in a very slow manner. So now we want to test whether the opinion of graduate and postgraduate respondents is similar, that is same or different. That means whether their opinion is independent or is there any association between their opinions. For this purpose, we are running a chi-square test. Now I'll show you how to perform chi-square test in Microsoft Excel. Here is our training evaluation form and here are the demographics. We are interested to know whether the opinion of graduate and postgraduate and doctorates related to pace of a training is independent or is there any association. Because why we are testing this is individuals, that is when they are graduate or a postgraduate, they may have some level of understanding, their knowledge levels may be different and their perception towards the training program may vary. Some may feel that the training program is leisure, some may feel that there is a hurry. So we want to know this so that in future when we conduct a similar kind of a training programs, we can manage the pace of our training sessions. So to test this, we use a chi-square test, and in Excel, you don't have a direct way of calculating the chi-square test. Here is the formula for a chi-square test, that is observed frequency minus expected frequency raised to the power of 2 upon expected frequency. And expected frequency is calculated as row total times column total upon a grand total. And to get a chi-square value, you need to know the degree of a freedom. So degrees of freedom is calculated as number of rows minus 1 times number of columns minus 1. Now first is that you need to have an observed frequency. So we can get observed frequency with the help of a pivot tables. So what is that we do is we place a cursor here in any one of the cells, then click insert, then a pivot table. So select a new worksheet and OK. So here your pivot table is running. Now here in a pivot table, what is that we are saying is we want to find out the relationship between education and pace of a training. So first we select the education, then bring it into rows box, then pace, bring this to columns box, then either pace or education you bring to the values. So here you got a values, that is observations are here. Total there are 150 respondents and their opinions, and you don't find much variation in the opinions expressed by graduates and postgraduates. Majority of them said that the program is conducted very leisurely, and a few said it is slow, and some said it is in a hurry. Now we want to see whether this opinion expressed by graduates and postgraduates are uniform or not. For this, what we do is you need to select this, copy, and we'll paste here, paste spatial, and we name this as education. So we have a grand total here, just we give a borders, and these are our observed frequencies. So we name this as observed frequency. The next is we'll copy this one and paste here. We name this as expected. So we need to calculate the expected frequencies. So for that, first we'll remove the values here. Then how is it we need to calculate the expected frequency? Here is a formula to calculate expected frequency, that is row total times column total upon grand total. So here for the first cell, this equals to row total is graduate, row total is this one. Select this times column total. Hari is in a column total 31. Select this one upon grand total. Here you have a grand total. Select this and press enter key. Now you got an expected frequency here. Try to drag this. You get a error message. Why you got error message here is just click on this cell and click on the formula here and observe the cells. So actually you want 31, that is I7, but it is I8 here. Similarly it is L7, but it is L8 here. So on the other side, if you try to drag onto the right side, here also you see instead of a column L, it moved to column M. To avoid this error, what is that you need to do is you have to make column L constant and row 7 constant in your formula. So to make a column L constant, place a dollar symbol before column L name. So here now column L, then you want to make a constant, that is a row 7. So insert one dollar symbol in front of a row number, then click. Then you want to make this particular cell constant, that is a grand total to be constant. So for making a grand total constant, you have to insert dollar symbols in front of a column name as well as row number. So this particular cell becomes constant. Now click OK. Then click enter. Now you drag to the down and onto the right. So your observed frequencies are ready. Now just to check whether observed frequencies are correct or wrong, equals to sum and select your values and click enter. So 150. So the grand total should be equal, that is grand total of observed frequencies and the grand total of expected frequencies should be the same. So we have a 150, 150. That means your calculation is correct. So to get a chi-square power value, we use Excel built-in function, that is a chi test. So this equals to chi. So here you have a multiple options. These first options are available from Excel 2010 onwards. Earlier versions have these below 3. So I take this chi-square test, double click on this, then select actual range. So we need to select the actual range. See that you don't select the grand totals. So only observed frequencies are selected here. Then place a comma, then select expected range. Then close the bracket, press enter key. Now you have a power value as 0.22. Now this power value we compare with significance value, that is a 5% significance level, or 0.05. If your p value is greater than significant value, then we accept null hypothesis. That means the opinions expressed by graduates and postgraduates related to the pace of a training program is independent. That means they have a different opinions on the pace of a training program. Now how is it we are going to get a chi-square value is, to get a chi-square value, just here equals to, click on a chi-square inverse, right? Select chi-square inverse, double click this, then your probability value already we calculated here, select this one, then place a comma, then degrees of freedom. So here your degrees of freedom is number of rows minus 1 times number of columns minus 1. How many rows we have here? Graduate and postgraduate, only 2 rows. 2 minus 1 is 1. And how many columns? 3 columns, hurry, leisurely and slow. 3 minus 1 is 2. So 1 into 2 is 2. So degrees of freedom is 2. Then close the bracket, press enter key. This is a chi-square distribution value. The lower the chi-square distribution value, the possibility of accepting a null hypothesis is very high. That means these two indicates that the opinions expressed by graduates and postgraduates related to the pace of a training program is independent. This is how you have to calculate the chi-square distribution test or chi-square test of independence in Microsoft Excel and test the hypothesis, whether you are accepting a hypothesis or you fail to accept the hypothesis. In my next lecture, I'll perform another chi-square test of independence on two other variables. Thank you for watching the lecture.